All right, so from this presentation, no, we can correctly say that there must be a leak kasi wala namang ibang ano binanggit sa problem na source ng losses. So, siyempre, swimming pool ito, definitely we can conclude na mayroong leak. Kung bakit umulan naman ng mas malakas kaysa doon sa lumabas by evaporation, eh sana instead na tumaas ang tubig, level ng tubig sa pool, hindi naman bumaba siya by 8 inches. So, it must have leak. Alright, so, tinatanong sa atin kung ano yung leak. It must have leak blank cubic meters. So, ilang cubic meters ang nawala. So, by applying the mass balance equation, di ba? Ang kuwan natin is in minus out equals change in storage. Dito ang nagbago ay in terms of depth units, kasi yung yung nagbago ay yung depth, no, in terms of depth units. Okay? So the change in depth okay, in terms of depth units, so ibig sabihin in minus out is equal to change in depth. So ano ba yung mga in? Ano ba yung in natin? Is the precipitation, di ba? Yung pumasok is precipitation. And then ano ba yung mga lumabas? Ang mga lumabas ay evaporation and then ano pa? Leak. Siyempre lumabas na yan. Itong leak. Lumabas na yan. So it's equal to the change in depth. Ano ba yung change in depth natin? Okay, isulat muna natin. Change in depth. Right. So, let's solve for the leak in here. So, solving for the leak is equal now to, okay, halimbawa, transpose natin. So, we have now precipitation minus evaporation, okay, minus change in depth. Okay? Can you still follow? Alright. So, ang kinukuha natin, yes. Ang kinukuha natin na unit, hinahanap natin na unit ng leak ay cubic meters. Volume, no? Volume unit. Leak in cubic meters. Okay? Parang masyadong makapal. Leak in cubic meters. Okay. So, alright. So, ano ang precipitation natin? Depth units, that's 7 inches. Okay? 7 inches. Minus evaporation ay 3.5 inch. Evaporation ay 3.5 inch. Tapos minus, okay, yung change in depth. Minus change in depth. 8 inches. Alright. 8 inches. Pero, dahil it recedes, sabi niya, bumaba, it must be negative. Okay? Minus 8 inches. So, it becomes now, in inches, it becomes now, di ba? Plus 8 yan. 15 minus 3.5 becomes, what? 11.5 inches. Tama? Okay, can you follow kung bakit may negative tayo dito? So, naging minus. Kasi yung change in depth natin, since sabi, it recedes by 8 inches. So, ang change in depth natin is minus 8 inches. So kapag i-substitute natin, i-carry natin yung negative, maging minus. So it becomes, okay, 7 inches minus 3.5, that is 3.5, tapos plus 8, so that's 11.5 inches. Pero ang hinahanap natin ay cubic meters. So, pwede nating may convert ito into meters. We can convert this one into meters. Pero ang hinahanap natin ay cubic meters. So, kailangan natin mag-multiply ng square meter, which is, okay, the area of the pool. Area of the pool. Okay, so i-multiply natin yung area ng pool, which is 20 by 20. Alright, so gawin natin. Okay. So since we are going to solve it in terms of volume unit, cubic meter. So 11.5 inches multiplied by the area of the pool, which is 20 by 20 feet. Okay. 20 by 20. So 20 squared feet squared. Okay. Tama? 20 squared feet squared. I-convert natin na meters yan. Convert din natin na meters ito. So, yung una, yung inches. In 1 meter, there are 39.37 inches. Para makancel natin yung inches doon. And then yung feet. Okay? Yung feet. In 1 meter, there are 3.28 feet. Okay? 3.28 feet. So since squared yon, so square din natin. Square natin yung taas. 1 square, meter square. Tapos square natin yung 3.28. Square din natin yung feet. Square. Okay? Para makancel na natin. Okay, dito, we can cancel now inches. We can cancel now square feet. So, ang naiwan ay meter times square meter. So, cubic meters. So, the answer in here is 11.5 times 20 is 20 squared, or that is 400. 11.5 times 400. Okay. Divided by 39.37 divided by 3.28 squared. So the answer in here, class, is 10.86. Tama? Yan ang lumabas. So the answer is letter D. Any question?
Sir, pa-screenshot naman po. Okay na, sir.
Okay. Next problem. Okay, in a study of a 1 hectare gently sloping watershed with a homogeneous soil type, what is the infiltration depth in mm if it rained for 30 mm per hour in 40 minutes and with a 15 times 10 to the 4th liters surface runoff out? Assume ET and percolation to be negligible. Number 41. Okay. So we're given in here a watershed with area of 1 hectare. Okay. So area is 1 hectare. Okay. And then there is a precipitation of 30 mm per hour in 40 minutes. Precipitation equals 30 mm per hour in 40 minutes. All right. And there is runoff out of 15 times 10 to the 4th liters. No? Runoff out of 15 times 10 to the fourth. 15 times 10 to the fourth liters. Then ET and percolation, per na lang, no? Percolation I 0. Okay, negligible. So the question is, what is the infiltration depth? Okay. Ang question ay infiltration depth in mm. Okay, so depth ito. Depth ang hinahanap. Depth unit. Depth units. Okay? So, anong equation natin? In terms of, kung ito, no? We're talking about rainfall, infiltration, runoff, evaporation. Okay? So, parang ang kwan lang natin dito ay yung form of the mass balance equation na precipitation minus losses equals runoff. Precipitation minus losses equals runoff. So yan ang parang basic equation natin. Okay? Ano ba yung mga losses natin? 'Di ba? So precipitation, yan lang yung pumasok minus ano yung losses natin? Wala namang ET losses, walang percolation losses. Ang consider lang natin na losses ay yung infiltration, P minus I. So is equal now to runoff. So ang sinusolve natin ay yung infiltration. So we have now P minus runoff. So given naman yung P, given naman yung runoff. Kaya lang ang sinusolve natin ay in terms of depth. Okay? In terms of depth. Now, isolve natin isa-isa. Yung P in terms of depth. Yung P, which is 30 mm per hour. Okay? In 40 minutes. So we're going to multiply 40 minutes, or that is what? 0.666. 40 minutes. 2/3. Tama? 2/3 hour? 2/3 hour. Okay. Para maging mm. So cancel yung R. Alright. So that becomes how many mm? It is what? 20 mm. 20 mm. Alright. Yung isa, run off out. Run-off out. Okay. Itong run-off out, liters ito. No? Liters yan. Pwede nating gawin itong cubic meters. Tama? Kasi volume yan eh. Pero ang hinahanap kasi natin ay mm in terms of depth. So kung cubic meters, pwede natin gawin itong cubic mm. Okay? Ito, dimensional analysis na naman ito. So, anong gagawin natin dyan sa cubic meters or cubic mm para maging mm lang or meter? We have to divide it by, okay, mm squared or meter squared. Tama? mm cube over mm squared. So, saan galing itong squared na to? It's the area. It's the area. Okay? It's the area of the watershed. So, yung relationship na naman dito, no? Yung relationship inano natin is the depth is equal to, okay, volume over area. Volume over area. Alright, so, yung runoff, ikuha na natin. Runoff is equal to 15 times 10 to the 4th liters. Okay? I-divide natin na sa area, which is 1 hectare. Ang 1 hectare ay How many square meters ang 1 hectare?
10,000, sir.
10,000 square meters. Or 10 to the 4th?
Yes, sir.
10 to the 4th square meter. Okay, yan yung area. Okay. So, mag-convert na tayo. Itong liters, gawin nating cubic meters. Tapos, yung lalabas na meter, gawin nating mm. Alright, so, in 1 cubic meter, there are 1,000 liters. So, okay. So, pagka kinancel natin units, liter, cancel liter, square meter, meron tayong meter na naiwan na isa. So, gawin natin mm yan. Alright? Mm. So, in 1 meter, there are 1,000 mm. Alright. So, yung 1,000 na yan, cancel na yan, 1,000, 1,000. Okay? Yung 10 to the 4th, cancel yung 10 to the 4th doon, tama? 1, 1. So, ang naiwan, mm na lang. Yung meter dyan, cancel na dun sa meter na naiwan na isa. So, ang naiwan na lang 15. Tama? 15 mm. Okay? 15 mm. So, ready na tayo para makuha yung I. So, dito na, substitute na natin, I is equal to P, which is 20, minus runoff, which is 15. So, that is equal to 5 mm. 5 mm. So, the answer in here is letter E. 5 mm. Screenshot?
Sir, may tanong po ako. Ano po
Yeah.
yung ET dun, sir? Ano po yung ibig sabihin ng ET, sir?
ET is evapotranspiration. Kasi watershed ito, pwedeng may mga pananim, that's why hindi lang evaporation. Yung kanina, yung swimming pool, no? Siyempre, yung swimming pool, evaporation lang, walang transpiration kasi walang tanim na nakalagay doon. While ito, watershed, so may mga damo, kahoy, okay, plants. Kaya usually ang ginagamit ay ET, evapotranspiration, combination of evaporation and transpiration.
So, sa losses po siya, sir?
Yes?
Sa losses po siya malalagay, sir?
Yes, di ba? Losses yan. Kasi ganito yan. Okay, illustrate ko lang para ma-identify natin kung losses ba o hindi. For example, ito yung kwan natin, watershed natin. So, yung ulan, pumasok yan. Di ba? Precipitation. Yung ET, lumabas yan. Nag-escape. Okay? Nag-escape yung ET. So, wala namang ibang binanggit na losses. So, ang isa lang ay infiltration, yung pumasok sa lupa. So, it's still considered as losses. Okay? Considered din na losses. Tapos, meron tayong runoff pala. No? May runoff din. Okay. Runoff. Yan. Lumabas din. Kasi, precipitation minus yung losses equals runoff. Di ba? Yung natin, form of our budget equation, water budget equation na precipitation minus losses equals runoff. So, panay losses yan. ET, infiltration, at saka yung ET and infiltration. So, yung difference nila, precipitation minus ET minus infiltration equals runoff.
Sige po, sir. Thank you po.
Okay. ET naman is 0 dito sa problem na to, no? At saka percolation, yung deep percolation. Ang meron lang ay infiltration. Kaya yun, yung equation natin na yan, yung nandyan. Okay? Alright, let's move to 42. So the change in water content of the soil in the above watershed is equivalent to blank cubic meter. Niya dito ay cubic meters. So alin dito sa illustration natin ang pumasok sa lupa na nagpabago ng kanyang moisture content? Is it the PETRO or infiltration?
Infiltration po, sir.
Yes, it's the infiltration. So ito 'yon. Is the infiltration. So anong gagawin natin sa infiltration? Dahil cubic meters ang hinahanap, so i-convert lang natin ito into cubic meters. So yun na. Okay? So ang pumasok lang sa lupa na nagpabago ng kanyang moisture content ay itong infiltration. So ito lang. So yung 42, okay, yung 42, number 42, the change in moisture content, delta MC, kana lang natin, no? The delta MC is equal to yung I. Okay? So ang I natin ay 5 mm. Para maging cubic meters ito, pwede natin ma-convert ito into meters, di ba? Para maging cubic meters, we are going to multiply it by square meter, which is the area. Okay, which is the area. Which is, anong area natin? 1 hectare. Okay, so multiplied by 1 hectare, or that is 10 to the 4th square meter. So yung mm gawin nating meter. So, okay, in 1 meter, there are 1,000 mm. Okay. Alright. So yung 1,000, cancel na yung cancel na yung 4 doon kasi 10 to the 4th, 10,000 yan, di ba? 10 to the 4th. So 10 na lang naiwan. So, yun na. Cancel na yung mm. Ang naiwan na is square meter times meter, so cube. So it becomes now 50 cubic meters. So that is letter E. Letter E also. Okay? Clarification? Or question?
Wala, sir.
Okay. Let's move to the next. Ito. 1 cubic meter of air can contain 100 grams of water vapor at a given temperature. But it has actually 50 grams of water vapor at an instant. What is its humidity in terms of grams per cubic meter and RH in percent? So ang answer dito ay 50 and 50. Letter B, no? Letter B. So, bago yan, no? Bago natin i-solve yan, sa humidity kasi, may tatlong klase, no? Sa humidity, there are 3. We have yung absolute humidity. Tapos merong relative humidity at saka meron yung what we call specific humidity. So yung absolute humidity is measured in say grams per cubic meter o di kaya mass per unit volume, no? Mass per unit volume. Pero itong RH naman usually measured in percent o di kaya decimal. Ito naman ratio, no? Ratio ito. Ratio. So since ang hinahanap ay in grams per cubic meter, ang hinahanap sa atin ay yung absolute humidity. Okay, absolute humidity. So ito yung actual na water content. Okay? It's the actual water content of a given air. So okay, so we're ready to solve now. So what is being asked in here is, okay, is the absolute humidity. So definitely, because the actual water content is we have, say, 50 grams of water in 1 cubic meter volume. So definitely that is 50 grams per cubic meter. 50 grams per cubic meter. So ito yung humidity na tinatanong sa problem. And then the other one, what is its RH? Di ba ang RH is, okay, kung ano yung it's the it's the water content based on the potential, no? It's based on the potential water content of a given air. Di ba ang sabi, okay, that 1 cubic meter of air can contain 100 grams. Pero ang nandyan sa kanya ay actually lang 50 grams. So ang RH mo na dito is, okay, yun na. 50 over 100, okay, multiplied by 100. Or that is 50%. Okay? So sa definition din ng kwan kanina, dun sa previous item, no, difference between humidity and relative humidity. So at an instant, ano yung kanyang, the ratio of the actual water content to its potential, no, amount that it can hold at a given temperature or at an instant. So yun, so the answer in here is 50 and 50. So it's letter B. Okay, any question? Let's move to the next. All right. Okay, in here, so 44, the catchment area of a reservoir is 10.5 square kilometer, while its water surface area is 0.45 square kilometer. On a particular day, a uniform precipitation of 0.5 centimeter per hour for 2 hours was observed in the catchment. The reservoir was observed for 8 hours. Runoff, estimated as 50% of P, reached the reservoir. A canal carrying 1 cubic meters per second is taken from it, while the rate of evaporation was 0.7 mm per hour per square meter. How much water flows into the reservoir? All right, so we have here a catchment. Parang ikaw natin, para maintindihan lang natin, no? Halimbawa, meron tayong watershed o catchment, nagdi-drain siya into a certain reservoir. Okay? Halimbawa, yan yung surface ng tubig. So ito yung catchment natin ng area is 10.5 square kilometer. Tapos itong reservoir natin ay meron tayong surface area average na 0.45. 0.45 square kilometer. So it says, umulan. Okay? On a particular day, a uniform precipitation of 0.5. So merong precipitation dito sa watershed natin na 0.5 centimeter per hour in 2 hours times 2 hours. Okay. So 1 centimeter kasi 2 hours na umulan. The reservoir was observed for 8 hours. So itong reservoir natin, ang observation time natin ay, ang delta T natin ay 8 hours. Okay? And then runoff, meron siyang runoff, okay? May lumabas. Runoff. Okay, which is 50% of P. Ay, hindi. Reach the reservoir, sabi niya. Okay, I'm sorry. Baliktad. Okay. Runoff estimated as 50% will be reach the reservoir. So, ibig sabihin, ang runoff natin, ito, galing sa watershed runoff, which is 50% or 0.5 of P. Yan ang naidagdag sa ating reservoir. But there is a canal emptying the reservoir. A canal carrying 1 cubic meter per second is taken from the reservoir. Okay? So, merong palabas na Q which is 1 cubic meter per second. Okay? And then there is evaporation, okay? May evaporation na lumalabas sa reservoir. Okay. Now, first question, how much water flows into the reservoir? So, ang tinatanong ay ito. Ito yun. How much water flows into the reservoir? Pero ang unit ay in cubic meters. Okay, so yun yung unang one natin. Sa 44. Right. Ulitin ko lang, no? So we have a 10.5 square kilometer catchment. Umulan dito sa catchment ng 0.5 cm per hour for 2 hours. So merong equivalent na 1 cm. Okay, so equals 1 cm. Na rainfall. Tapos, may runoff na 0.5 P. Runoff na 0.5 P na nadagdag galing sa watershed na dagdag dito sa ating reservoir. Pero yung reservoir, meron ding evaporation at saka meron ding kinukuhang tubig na 1 cubic meter per second. Ang observation time sa reservoir ay 8 hours. Okay? So, ang unang tanong, how much water flows into the reservoir? So, it's this RO. So, yung RO natin is equivalent to 0.5 P. 50% of P. Pero ang P natin ay, di ba? 0.5 cm per hour times 2 hours. Okay? So, that is equivalent to 1 cm. 1 cm. Ngayon, i-convert natin ito, okay, into meters. So, this is already 0.001 meter. So, meter na. Ang kulang natin kasi hinahanap natin is cubic meters. So, i-multiply natin yung area ng reservoir. Tama? So, the runoff in cubic meters is equivalent to 0.01 meter multiplied by the area. Okay? So, 0.01 meter multiplied by 10.5 square kilometers. So, ilang square meters ba ang square kilometers? 1,000 times 1,000, di ba? Times 10 to the 6. Kasi ang 1 kilometer ay 10,000 meters. So in terms of square meters, ang 1 square kilometer ay 10 to the 6. Tama? Right. Para ma-verify lang. Yung area which is equal to 10.5 square kilometer, convert natin square meters. So, yung 1 kilometer, there are 1,000 meters. So, square natin yan, square natin yan, square natin. So, 10 to the 6, no? Kasi 1,000 squared is 10 to the 6. So, 10.5 times 10 to the 6. Right? So, computin natin yan. It becomes 52,500 cubic meters. So, the answer in here is letter D. Letter D. Question?
Answer.
Okay. Next, let's go to the next. The total evaporation loss in the above reservoir is blank cubic meters. Alright, so sa 45, Ang hinahanap natin ay evaporation in cubic meters. Alright. So, pero meron tayong given na evaporation which is, okay, 0.7 mm per hour per square meter. Alright. Meron tayong given. I-convert lang natin yun, no? Ang tinatanong ay E in cubic meters, pero ang meron tayong data ay 0.7 mm per hour per square meter. Alright. Dito ako nagkaroon ng typo error class. Dapat ang given dito ay 0.7 mm cube. Okay? So definitely ito ay bonus na naman. Bonus. Okay? Bonus point. Alright, pero ganun pa man, isolve lang natin no, kung paano natin kuhan. So instead na kuhan, yung given sana na 0.7 mm per hour per square meter, dapat ito 0.7 mm cube. Okay? So na-omit yung cube. So para maging cubic meters ito, dapat makapag-multiply tayo ng hours, which is yung delta T natin na 8 hours observation time, at saka yung area ng pool. Okay? So madali na lang. So 0.7 mm cube per hour square meter. Okay? Multiply lang natin yung 8 hours, which is the observation time, multiplied by the area, 0.45, okay, 0.45 square kilometers or times 10 to the 6 square meter. Tapos yung mm, okay, yung mm i-multiply natin ng i-convert natin to meters. So we have, say, in 1 meter there are 1,000 mm. Pero i-cube natin. I-cube natin kasi cube yun eh. Cube natin yan. I-cube natin. I-cube natin din. Para makancel yung cube. Okay? So, cancel yung hours. Cancel yung square meters. Ang maiwan ay cubic meter. So, dapat ang sagot natin dyan ay 0.00252. 0.00252 cubic meters. Alright. Kaya bonus yun, no? Kasi nagkaroon ng pagkakamali dun sa unit ng E. Okay? Now, sa next item, assuming seepage loss to be 50% of evaporation loss, what is the change in the reservoir level in millimeters? So, dahil mali yung data dito sa 45, yan ang gagamitin natin sa 46. Definitely, yung 46, bonus na rin. Bonus point. Bonus item. O, ilan ang bonus item? 5 na. 5 na. Okay? Pero ganun pa man, ikuan natin, isolve lang natin para maintindihan lang natin dito. So, assuming seepage loss to be 50% of evaporation loss, what is the change in the reservoir level in millimeters? So, paano natin kukunin yan? So, ang hinahanap ay what? Change in depth. Kasi meron na tayong seepage loss, no? It says, the seepage loss is 50% of ET or 50% of evaporation. So, that is 0.5 times E, or that is 0.5 times 0.00252 cubic meters. So notice ito class, cubic meters na ito. Okay? Alright. So by using now the mass balance equation, in minus out equals change in storage. We're talking about the pool now, okay? Kasi ang nagkaroon ng seepage loss, okay? Nagkaroon ng loss dito ay sa pool. Ay sa what I mean is dito sa reservoir. Okay, sa reservoir. Alright, so ano ba yung mga in sa reservoir? Ang in sa reservoir ay yung runoff. Runoff na nanggaling sa watershed. Ano yung losses niya? Yung Q, marahil ginagamit sa patubig. Yung E, evaporation. At saka, merong nadagdag yung seepage. Yan. Okay. So, ito na, gamitin natin. Ano yung in lang natin? RO. Yan ang in natin. Minus yung mga out natin. Yung mga out natin ay we have minus evaporation, minus seepage loss. Okay. Minus Q, yung pinampapatubig. So, equals change in storage. O in terms of depth. Depth nang hinahanap kasi eh. In terms of depth. Change in reservoir level. So, change in depth na ang pa natin. Yan. Change in depth. So, ibig sabihin, lahat ng items na to na runoff, evaporation, seepage, gawin na natin in terms of depth. In terms of depth. So, yung runoff, ang nakuha natin ay in terms of cubic meters. So, i-divide natin yung area ng watershed. Yung evaporation naman na nakuha natin doon sa pool, sa reservoir, ang nakuha natin in terms of cubic meters, i-divide natin yung area ng surface area ng storage ng reservoir. At saka itong seepage yan in terms of na naman ito, in terms of cubic meters. So gawin natin i-divide natin yung area ng reservoir. So ganun 'yun. All right, so let's do it. Ang una is yung around 52,000 cubic meters. So yung runoff. So we have yung runoff equals 52,500. Ganun ba yan? Yeah, cubic meters. Cubic meters divided by area of the watershed, 10.5 square kilometers, so times 10 to the 6 square meter. Okay? Pero mm ito. So ito, cancel na yung square meter sa meter. So i-convert natin, gawin natin mm times 1,000 mm per meter. Alright, para cancel yung meter. So this becomes now, ang RO natin ay, okay, yan. Okay, you can compute that one. And then yung next, evaporation. Okay, yung evaporation na 0.00252. Okay. So evaporation na 0.00252 cubic meters. I-divide natin yung area ng pool, that is 0.45. Okay, times 10 to the 6 square meters. Cancel yung square meter sa meter. And then, gawin nating mm. So, yung meter, okay, 1,000 mm. So yan, so cancel na lahat yung meter and then ang naiwan ay mm. Again. So another mm. Yan, mm din ito. Tapos yung isa, yung Q. Yung Q or RO out, no? yung Q natin which is 1 cubic meter per second. So ano ang kailangan natin gawin doon? So yung 1 yung Q, no? Runoff out. 1 cubic meter per second. So we have to multiply this by 8 hours. Okay? Para makuha natin yung cubic meter, so we have to multiply this kasi 8 hours yung delta T natin. Okay? 8 hours. Okay? Times in 1 hour, there are 3,600 seconds in 1 hour. Okay, so cancel na yung second natin, cancel na yung hour natin. Ang naiwan pa is cubic meter. So, mag-divide tayo ng area. Area of the pool, that is 0.45 times 10 to the 6 square meters. So, cancel na yung square meter. Tapos mag-multiply tayo, gawin nating meter na naiwan, gawin nating mm. So, we're going to multiply 1,000 mm per meter. So, ang unit natin dito ay mm. So, isolve na natin. Meron na tayong ROE, losses, yung losses, 50%, no? Yung losses, yung seepage loss, which is equal to 0.5. Meron na ba? Solve kanina. Yan. Ito to. 0.5 times 0.0052 0.005252 cubic meters. Okay. So we have to divide this by area of the pool, reservoir, 0.45 times 10 to the 6 square meter. So cancel na yung square meter na yan. Tapos meron pang i-convert natin into mm. 1,000 mm per meter. Para makancel yung last na meter. So ang lalabas dito ay mm. Right, pinagko-combine natin ito. Solve for delta D. Delta D is equal now to RO minus E minus seepage loss minus Q. Okay? So, substitute na lang natin kung ano yung mga values natin dyan, and then it becomes, ang sagot ay 52.66 mm. 52.66 mm. Okay? So that's how to solve for number 46. Change in depth. Change in depth. Pag lumabas na positive ang change in depth, ibig sabihin nag-increase yung depth ng reservoir. Pero kapag lalabas na negative, nag-decrease ang depth ng reservoir. That's what it means by change in depth. Question?
Wala po, sir.
Okay, let's move to 47. Alright, dito sa 47, we have a big watershed pero subdivided into 3. So parang kung ito, no? Parang big watershed na ganyan pero na-subdivide siya into 3. Say A, B, C. So malaking watershed subdivided into 3. Ang tinatanong dito is, what is the annual runoff? Kapag ka meron tayong sub-watershed A, 61 square kilometers, tapos 52 annual runoff, in cubic meters. Sub-watershed B, 39 square kilometers, tapos 42 centimeter runoff, and sub-watershed C. Okay. So parang ganito, pwede natin gawin ganito, no? Sub-watershed A, B, C. So, area and then runoff. So, ang area ng A ay 61. Ang runoff niya ay 52. Yung B ay 39. Ang runoff ay 42. And then 20, 32. So baka kaagad pwede nating matempt tayo na kukunin na yung total, no? 61. This is already 120 square kilometer. Tapos ang runoff naman nito, pag tinotal natin ito, 126 cm. Para kinompute na natin, ang runoff na niya is 126 cm per, ano bang tinatanong? Annual runoff in cubic meters, no? Cubic meters. So, multiply na natin yung area, which is 120 times 10 to the 6 square meter. Parang ganun, no? Pero it's not. Hindi natin basta kunin yung total area, tapos total runoff. And then we multiply them para makuha natin in cubic meters. This is wrong. Kasi magkakaiba sila ng, kaya nga na-subdivide into sub-watersheds kasi magkakaiba sila ng maybe geology, topography, vegetation, and everything. So magkaiba ang, hindi siya homogeneous, no? Magkakaiba. That's why you have to solve separately. We have to multiply this separately. Okay? Yan. And then take the summation. Okay, so 65 cm times 52 times 10 to the 6 or 0.65, no? 0.65 times 52 times 10 to the 6. Parang ganon, no? Ganon ang pattern. 0.39 kasi we're talking about cubic meters. So ang lalabas dito, cubic meters. Cubic meters. Cubic meters. Okay? So ang total nito, right, 0.39 times 42 times 10 to the 6. 32 times 10 to the 6. Ganyan, no? 0.2. Okay? Multiply. Yan. So that the overall answer for number 47 ay 54.5 times 10 to the 6. 54.5 times 10 to the 6 cubic meters. So dito sa sagot, it's either letter A, 54, it's either letter C, 54.8, o di kaya or your own answer, kasi nga wala dito eh. Pero wala naman kasing choice na none of the above. So ang kwan naman, ang tawag dito, ang instruction is choose the best answer, di ba? Choose the best answer. So what's the best answer here? Wala naman tayong none of the above. So it is 54.8. Letter C. Pero ang instruction ko kasi pag wala yung answer nyo dyan sa mga choices, feeling nyo answer nyo ay tama, you just write your own answer. So it's either C or you have written your own answer, which should be 54.5 times 10 to the 6. Okay? Alright, next, ito. Sa number 48. So we have a given area which is 100 hectares. Or 300 hectares, I should say. So 300 hectares or 300 times 10 to the 4th square meters. Okay? So we have also a precipitation which is equal to 100 mm. And then delta T, ang observation time natin is 10 hours. And then we are given ratio, runoff over P ratio, which is 0.2. Alright, which is 0.2. So ang tinatanong dito ay, what is the average stream flow in cubic meters per second at the outlet during this 10-hour period? So halimbawa, dun sa drainage sa baba sa kalsada, no, umulan sa Abida and CSU, lahat ng tubig pupunta doon ng runoff. Observation time is 10 hours. So, ano ang pan natin? So kapag dito, so ang runoff natin is equal to 0.2 of precipitation, or that is 0.2 times 100 mm, or that is equal to 20 mm. So, ang hinahanap sa atin dito ay yung runoff rate. Okay? Runoff rate, o di kaya sometimes ginagamit natin ng Q, which is in cubic meters per second. So, ibig sabihin, itong runoff na to, na 20 mm, convert lang natin into cubic meters per second. So, itong 20 mm, that's equivalent to what? Divided by 1,000, di ba? Para maging meter sana ito, no? Maging meter. So, 0.2 times 0.1. So, 0.02. 0.02 meters. Tama ba yan? 0.02 meters? Alright. So, this becomes now 0.02 meters. Anong i-multiply natin para magkaroon tayo ng cubic meters per second? Okay. So, ito yung formula natin. QT equals AD. Yan yung formula natin. So, ang kinukuha natin ay Q. Q is equal to AD over T. So, we have to multiply, okay, itong depth na ito, we have to multiply by the area, which is 300 times 10 to the 4th square meters, and then divided by the time. Gawin nating seconds. Yung time natin is 10 hours. Okay, convert natin into seconds. So, we have to multiply by 3,600 seconds. So, alisin na natin yan, per hour. So, cancel yung hour. So, the answer in here is 1.66. 1.66 cubic meters per second. So, ang answer dyan ay nota. Nota. Okay, none of the above. Tapos may nagtanong sa akin sa ibang section, Sir, ang nilagay kong sagot ko ay 1.66 cubic meters per second. Tama ba? Tama yung sagot mo na 1.66 cubic meters per second. Pero ang answer mo sa question should be none of the above. Kasi may choice tayo na none of the above. Okay? Next, 49. Okay, tapusin na lang natin. Konti na lang. Latent heat of vaporization, meron tayong formula nito. Latent heat of vaporization is the amount of heat absorbed by unit mass of substance without change in temperature while passing from liquid to vapor state. How much heat in kilocalories needed to vaporize 1 liter of water at room temperature 20 degrees centigrade? Meron tayong formula. H is equal to certain value minus certain subscript and then multiplied by T in degrees centigrade. Can you remember the formula?